All right, so welcome to day 4 of Unit 1. We're going to be talking about angles and their vocabulary today. Much like we started off the unit talking about points, lines, and planes, and then segments and rays and how to name them, how to solve for lengths of segments, what if they're congruent. We're going to do all of that kind of stuff again today, but with angles. Okay, so again, my disclaimer, I'm going to go through this pretty quickly. If you feel the need, if I'm going too fast, just stop, pause, rewind, right? Listen to it again. All right, so the first one is, what is an angle? So obviously there is an angle pictured right here. So an angle is formed by two rays that share a common endpoint. Okay. Now, even though these are, of course, rays, right, that share endpoint A, angles themselves have their own vocabulary, right? So the rays, we actually call them the sides of the angle. And then the shared endpoint is, of course, called a vertex. Okay, so we have the vertex of the angle and then the two sides that form the angle. Now, you are going to have to name angles quite frequently, right? And so there's basically 3 ways to name an angle. I'm just going to number them right here. I'm going to put a little star next to the first one because this is the first way that I'm showing you is probably going to be your go-to, like 90+% of the time. Okay, so when you name an angle, the easiest way to go about that is to use 3 letters. First of all, you want an angle symbol. So I draw my angle symbols like this with an arc. If you just want to draw your angle symbol like that without the arc, that is totally fine. So we draw the angle symbol so our reader knows that we're talking about an angle. And you have to use 3 letters. And the order is extremely important in these 3 letters, right? It's not like when you're naming a plane with 3 letters and they can be in any order you want. So to name the angle, it has to be in the same order as if you were to trace the angle with your pencil. So for example, if I start up here and I start traveling and tracing the angle, I'm going to hit point T first. All right, so I hit point T, then I hit point A, and then I would finally hit point P. So in order, I would call this angle TAP because that is the order I hit the points that are lettered as I trace the angle. Now, obviously, I could also go the other way, right? I could start at point P. So I'm going to write or angle PAT. Notice in both of these scenarios, the A is the middle letter because, of course, the vertex will always be the second stopping point with naming it with 3 points. All right, again, this is kind of going to be your go-to, okay? Sometimes, especially if a picture is super busy and there's lots of angles going on, you may occasionally see a number. I'll just put a 1 right here. It could be a 1, 2, 3, 4, 5, whatever number it wants to be. So you might notice a number inside the angle near the vertex point. If you see that in your diagram, then instead of using the 3 letters to name the angle, you are welcome to just name it angle number 1. And that is okay. The third and final way that we can name an angle is by simply using its vertex only. So clearly I am only looking at one angle here with a vertex of A. So I could just call it angle A if I want to. Now this one you have to be careful. I'm going to kind of write over here. All right, so I'm going to write be careful with this one. All right, I'm just going to draw a little illustration here. Let's see, TAP. I'm going to kind of redraw that same angle, that TAP that's over there off to the left. T, A, and P. And of course, what if I decided to split the angle somehow, right, and add another ray, right? In this scenario, I cannot call this angle A because there's clearly more than one angle happening that is using vertex A. So if I told the reader that the measure of angle A was 42 degrees, they would have absolutely no idea which angle I was talking about. So in this case, I would not be able to use this third option and call this angle A, right? That would be a no-go. right? So the only time I'm ever able to use option 3 is if there's only a single angle happening with a vertex of A. Okay? All right, let's go talk about types of angles. You learned these in elementary and middle school, so these should all kind of sound familiar. So an angle whose measures between 0 and 90 is an acute angle. So I'm just going to draw an illustration of that. So there's my first side, and then anything that's between 0 and 90. So I'm referring to this angle here. I am aware technically, if you might be thinking this, there is another angle, like this big guy all the way around. That's also another angle, but our human brain, when we see an angle, we automatically go to the smallest angle. And you're going to want to do that most of the time in this class. We're going to talk about that big angle here in just one sec, though. All right, an angle that is exactly 90 degrees is a right angle, which of course looks like this. And don't forget, the only way you can prove without a shadow of a doubt that it's a right angle is if you see a right angle box in the corner, right? If that right angle box is not in the corner, then you may not assume that it is a 90-degree angle, even if it looks like one. Okay, you have to be able to prove things are true. You are not allowed to make assumptions. All right, an angle between 0 and 90 and 180 is an obtuse angle, right? So we're going beyond 90 degrees, but still less than 180, right? So this would be an obtuse angle here. And then we have the angle that's exactly 180 degrees, and that would be a straight angle. So we have one ray shooting that way, and a straight angle would look like this. Right, so this right here, always exactly 180 degrees. Now, obviously, if I was to just ask you about this picture, you could not only say it's a straight angle, but you could say they're opposite rays and it's a line, right? So we've learned enough vocabulary where you can start seeing that some things can double up in meaning. But what's important is making sure that you understand in context, which thing I'm talking about, right? If I was talking about this thing having 180 degrees, then we would be referring to it as a straight angle, okay? And the last one is not really one you have to memorize or know. It's just kind of there for you if you want, is what happens if we go beyond the 180, right? So if I do something like this, now again, our human brain automatically kind of goes here, but if I start here and I go all the way around, now I've exceeded 180 degrees, and this has a special name. It's called a reflex angle. Again, you don't have to know that. It's just kind of a extra little tidbit of information. All right, our next big topic is making sure we talk about congruent angles, right? Just like we talked about congruent segments, we're going to run through basically all that same stuff with angles. So you can clearly see, I'm hoping, that in this picture, we have two angles that both have the same measure of 52 degrees. That would make them congruent. And of course, every time you find anything congruent in a diagram, you should always mark it. So if you remember from last week, we briefly mentioned that when you have angles, you would mark congruencies using arcs, similar numbers of arcs. So in each one of these, I would put a single arc, and that would tell my reader that they were congruent, okay? Obviously, the 52 degrees normally would not be there, right? If I had another pair of congruent angles, then I would have double arcs and then triple arcs and so forth. Now we need to talk about the proper notation. If I'm just saying that these two angles are congruent, well, that's pretty easy. I just need to name them. So angle, all right, if I'm naming this angle over here, remember, trace it with your pencil, right? So you could either say SRP or PRS. You would not be able to just say angle R because there are too many angles using vertex R. So I would just say angle SRP is congruent to angle PRQ or QRP. So that's how we write congruent angles. Very simple, just like with segments. Now, if you want to actually refer to the numerical measure of the angle in degrees, well, that means we're going to be using an equal sign, just like we talked about with segments, right? Remember, notation's a little bit different with equal signs because with segments, we took off the segment bar. Well, angles are the same. There's a little twist to it. So when I want to say that angle SRP is 52 degrees, I have to also make sure I put a little lowercase m in front, and that stands for the measure of. So you can see we have a complete sentence here. The measure of angle SRP is 52 degrees, right? We want to make sure we put the degree symbol on there because that's like our unit of measure. It's no different than like feet or inches. And we could keep rolling here. We could also say that the measure, I'm just going to write and, the measure of angle PRQ is 52 degrees. And if you wanted to keep going, you could also say that the measure of angle SRQ, which is the whole angle, right? Sorry, I forgot my degrees there. Wouldn't that have to be 104 degrees? Because just like we learned with segments, right? Any two parts, right, has to equal the whole thing, or 3 parts or 4 parts, however many parts it's divided up into. We'll talk more about that in just a few seconds. All right, the other vocab word we need to know is angle bisector, right? So an angle bisector, we already know what the word bisect means. So anywhere you see it, right, you know something is getting cut into 2 congruent parts. So in this diagram, since both angles are 52 degrees on either side of ray RP, that means that ray RP is an angle bisector, right? And of course, the formal definition is right there, right? Anything that divides an angle into 2 congruent angles. It could be a line, it could be a ray, it could be a segment, right? It doesn't have to be a ray. You could cut, if you wanted to, this could cut all the way through like this and be a whole line, right? As long as it's cutting that 104 degree angle in half. All right, so really quick for some practice of just naming angles and finding proper ones, we're going to answer these questions. So name an acute angle in the diagram. Well, there are 2 of them. So you could either say, I'm sorry, let me not write in highlighter. There we go. Angle XAZ, right, which would be this angle right here, clearly acute, right? And you don't have to name all of them. I'm just going to. And of course, angle YAU, right? Because he's 50 degrees, which is definitely less than 90. All right, the next one is asking for a right angle. Well, remember, we're clue finders, so there's my right angle, right? Because I see that right angle box. So angle ZAY would be an appropriate name. Notice my middle letters are all A's because A is the vertex point for all the angles in this picture. All right, next one is an obtuse angle. Now there's a couple of different ones here. Obviously, you're going to have to put 2 angles together, right, to form an obtuse angle. So something like this, right? If I was looking at this whole angle right here, then that would definitely be obtuse. So angle ZAU would be an answer there. There's other answers. Of course, XAY would also be an acute angle, so you could put that as well. And then our last one is a straight angle. Well, clearly there's a straight angle because I see a straight line. So make sure when you're naming your angle, you still are using 3 letters, X, A, U, with A in the middle. All right. So while we're, before we get to that next question, I want to make sure we understand, can we find the measure of this angle right here? Right? Because again, you need to be a clue finder. So we automatically know that that's a 90-degree angle. So if we add these 2 together, right, we know that that's 140 degrees, right? But of course, we know that this whole thing is a straight angle, right? Oh, there I am. I'm going to go all the way around. So we could just use basic arithmetic, right? If I already know 140 degrees is taken up and the whole straight angle is 180 degrees, then that automatically means this guy right here is 40 degrees, right? Which of course proves it's acute, right? All of our answers all add up to 180, so we're good. But I kind of want to do that to answer that 5th question there. Is there an angle bisector in this diagram? Well, remember, if it's an angle bisector, that means it's going to produce two congruent angles. Do we have two congruent angles anywhere in this diagram? No. Right, the only angles we have are 40, 90, and 50. So there is not an angle bisector in this diagram. So no, there are no congruent angles. And of course, they have to be side by side, congruent angles, right? They have to be on either side of that shared angle bisector. All right, the last thing we're learning today is the angle addition postulate, which we've actually already applied multiple times already in these notes, right? Just like we did right here to kind of figure out what the missing angle was, and just like we did up here to figure out that the whole angle was 104, right? We were using the angle addition postulate, right? Because it's just common sense. It's the same thing as our segment addition postulate, right? That says if we add up the two smaller angles, it has to equal the measure of the entire large angle. Right? And so before we actually write that down, I just want to focus on a couple of vocabulary words here in this definition. It says if W is in the interior of angle EDC. So of course that just simply means that when I draw it, right, EDC is my main angle, and then W is somewhere in the interior where I'm drawing that third ray to do the split. Okay? And then it says it will obviously create two adjacent angles. Right? We'll define that more tomorrow, but remember adjacent from your vocabulary in English class, right? Adjacent means next to, right? So clearly these two angles right here are next to one another, right? Because they're sharing ray DW. Okay, so that it has to look like this picture in order to use the angle addition postulate. Okay, so we can simply use our picture to write an algebra equation. Now keep in mind, we are writing an algebra equation. I'm going to scroll back up here. We're using an equal sign, which means we are referring to its actual numerical measure, which means we need to make sure we're using the m's for measure when we write our equation. So I would write the measure of angle EDW, that top smaller angle, plus the measure of angle WDC, right, the lower one. If I add those two together, it has to equal the measure of EDC, right? The whole angle. And again, this is still part plus part equals whole, just like the segment addition postulate. And remember, it doesn't just have to be two parts, right? If you see an angle split into 5 parts, then it's part plus part plus part plus part plus part equals whole, right? The whole thing is always equal to the sum of all of its parts. Now you'll notice on the bottom of the page here, I still have angle EDC with W in the interior for both of these, right? Here's straight angle with W in the interior. But these are pictures where you need to take notice because there is a clue that you need to find, right? And clearly on this one, our clue is that it is a right angle. Right, and you have to pick up on that. So they're not going to tell you that those two smaller angles add up to 90 degrees. You have to be able to look at the picture and be like, oh yeah, that means the measure of EDW plus the measure of WDC, which is exactly what I wrote just right above in the box. But I don't have to be told what the measure of angle EDC is or an expression for it. I automatically know it has to be set equal to 90. Because it's a 90-degree angle. Notice I didn't put the degree symbol because we don't put units of measure in algebra equations, right? You would never put feet or inches or miles inside of an algebra equation. Same thing with degrees. That is 90 degrees, but I'm just not going to write the degree symbol, okay? And of course, the same thing on this picture. This is a very special angle because it is a straight angle, right? Therefore, it has to add up to 180 degrees. Right? That is something you have to notice, right? Oh, all straight angles are exactly 180. So once again, I can write that same beginning equation, that the measure of EDW plus the measure of angle WDC, but now I know it has to equal 180. Nobody needs to tell me that because it's a clue I need to pick up on in my picture. Okay? All right. We're going to do two quick examples here. You'll notice in these two examples that there is no diagram. So of course you should be drawing the diagram and reading very carefully to make sure your diagram is accurate, right? So here we go. Given angle AOC with P in the interior. Stop. I'm not even going to read the rest of it. I'm just going to draw that right now. So angle AOC. So, and again, I have no idea what the measure of AOC actually is. I don't need the picture to be like dead on accurate. I need it to just be labeled accurately to act as a visual aid so I'm setting up my algebra equation correctly. So there's my angle AOC. Again, it just says P is somewhere in the interior. I have absolutely no idea where it is in the interior. So I'm just going to randomly put point P there. I'm going to connect it to O because that's the intention. So it's splitting the main angle into two parts. And then I can just label everything from there. So if I keep reading, it says the measure of angle AOP is 3x minus 1. So I'm going to write that in. AOC, which happens to be the whole thing. So again, make sure you're reading carefully and labeling it appropriately. If you put labels in the wrong spot, then the numbers are not going to mesh. And then COP is 5x plus 5. Well, clearly, they've given me an expression for the measure of the small angle, the measure of the other small angle, and they've given me an expression for the whole thing. So this is obviously the angle addition postulate, which will allow me to add the two smaller angles together and set it equal to the whole angle itself, right? This is the angle addition postulate. I'm going to write that over here because remember, we need to start thinking about how to justify everything we write down. Oh, I just wrote an angle. I'm going to abbreviate this a little bit if everyone's cool with that. Angle addition postulate. Right, every time you write an algebra equation or anything down, you want to ask yourself, what is allowing me or justifying this step? Right, so the angle addition postulate is what allows me to write that algebra equation. There we go. Okay, now we can solve. If you want to go ahead, if you want to go ahead and combine like terms without having to write out that whole first step, that's totally fine, of course. And just write 8x plus 4 equals 9x minus 3. We get all our x's to one side, all of our constants to the other, and voila, we should be getting x equals 7. Now, some of your homework problems or test questions or whatever may just ask you to solve for x, so you'd be done. But you're not really done because you should totally be taking the extra 5 to 10 seconds to plug that x value back in and see if your numbers work, right? And so this one actually asks us to find the measure of all the angles, so I'm going to do that. So I'm going to do the two smaller angles first. So AOP, the measure of angle AOP. So I'm going to take that 7 and I'm going to plug that in for the x into 3x minus 1. Well, 3 times 7 is 21 minus 1, so I'm going to get 20 degrees for the measure of angle AOP. Then I'm going to do the other one, which is COP. So I'm going to take that 7, I'm going to plug it into 5x plus 5, which is going to give me 35 plus 5, so he's 40 degrees. All right, so far so good, but that doesn't check my work until, of course, I go find the measure of angle AOC, which I clearly know should be 60 because that's what 20 plus 40 is. But I'm going to make sure mathematically that if I plug a 7 into 9x minus 3 that I actually do get 60. Well, and you do, right? Because that's 63 minus 3. So yay. I plugged it in. I'm gonna put a little check smiley face, right? There's absolutely no doubt that I have done this problem correctly, right? It's 100% correct. I didn't make an error in drawing my picture. I didn't make a silly math mistake with my algebra. I automatically know that that is a 100%, right? And then I can move on. All right, example number 2 has a little twist to it because remember, we're clue finders, so you have to make sure that you are seeing all of the clues. So here we go. It says given angle AOC. Okay, I'll stop right there. I'm going to go ahead and draw AOC. A, O, and C. Okay. With M in the interior and on the angle bisector. That could not be a big enough clue, right? It's not only is M in the middle, but it lies on the angle bisector. It's not like this first question where we were like, okay, point P is in the interior, which just means anywhere floating around in the interior. this M is in a particular spot, it has to be on an angle bisector. Which, before I start writing anything else down, I should write in my picture, I should be putting arcs to show, oh, a bisector splits an angle into two congruent angles, right? I need to make sure all of those clues are in my picture for me. And now I can fill in that angle AOM is 7x minus 5, and angle MOC is 4x plus 10. Now you'll notice I do not have an expression that represents the whole thing, which is why I can't possibly use the angle addition postulate on this problem. But I do have congruent angles. And anytime I find a congruency, that means I can set things equal to each other. So I know the 7x minus 5 angle has to be the same as the 4x plus 10, right? And so I can subtract the 4x and then add the 5 and then divide, and voila, x equals 5. And again, I'm going to plug it back in. I know it asked us to on this particular problem, but even if it didn't, I totally would. Right, so here we go, the measure of angle AOM. Well, let's see, if I take that 5 and I throw it in over here, that's going to give me 35 minus 5. Right, so that's going to give me 30 degrees for the measure of angle AOM. And of course, if I've done all my math right, then the measure of angle MOC has to also be 30 degrees. But I'm not going to just assume that, right? The whole point is to check your math, so we're going to plug it in over there. Well, 4 times 5 plus 10, yeah, that does give me 30. So again, I'm going to put a little check mark smiley face, right? That means all of my math, all of my numbers jive, right? They all work together. I am 100% sure of my answer. If you also, I know it said all the angles, so if you also want to write AOC, you certainly can, and we would use the segment addition postulate, the angle addition postulate to, of course, write that that's 60 degrees. All right, so that's pretty much it for today, right? Some basic angle vocabulary, and then using that angle addition postulate or any other vocabulary clues that we might be given, okay? The very last thing, just really quick, this just is kind of a good quick day to talk about this. I keep mentioning that you can never make assumptions in geometry. There's very, very few things that you're able to assume are true. Everything else has to be proven and justified, right? That's what we're going to be doing for the next 17 weeks, right? Is proving things and justifying why they have to be true. So let's just talk about really quick what you can assume. Notice it's a very short list. And most of these things you wouldn't even think about. They're just so common sense that you wouldn't think about assuming them versus not assuming them. So here we go. If this is our diagram, all right, with all these rays and angles happening, you can assume that all the points in that diagram are coplanar. So that is a flat two-dimensional drawing, and they're all existing on that flat surface, which you probably wouldn't even think twice about. But basically what that's saying is, like, let's say, for instance, if the intention of ray BE was to be like shooting out of your paper, like towards you and making it three-dimensional, right? That's not happening, right? This is a two-dimensional drawing and everything is flat. You can also assume that points A, B, and C are collinear, right? That's a pretty big one, right? If it looks like a straight line in here, you can assume that it's a straight line. We're never going to give you a line that's a couple of degrees off and be like, no, sorry, there was a slight bend in there that your human eye could not even decipher, right? So if it looks straight, you can just run with that, which of course piggybacks into number 3, that angle ABC then is a straight angle, which of course means it adds up to 180 degrees. We can also assume that all of the lines in that picture or rays intersect at point B, which I think is, again, pretty understood. No one would think twice about that. Basically just saying that there's no, there's not any gaps, you don't have to worry about that. And the last one kind of piggybacks after number 1, that point E lies in the interior of angle DBC. So again, it's just reinforcing the fact that that is a two-dimensional drawing and not three-dimensional. Okay. All right, the most important part, though, to me is what you cannot assume. So these are probably the three biggest mistakes that students make at first, right? Assuming things about the picture to be true that you can't possibly. So in this one, you cannot assume that point B is the midpoint of segment AC. No matter how much it looks like B is smack dab in the middle between A and C, I can't make that assumption at all. So what I'm going to do is down here on this picture, I'm going to write what the picture would have to look like for me to be able to make that assumption, right? And of course, I would clearly have to have congruency marks to prove that B was the midpoint, just like we talked about last week. Secondly, you cannot assume that ray BE bisects angle DBC. So again, no matter how much it looks like this ray right here might be cutting DBC in half, we obviously cannot assume that unless, of course, we see congruency arcs. And lastly, we cannot assume that angle DBC, right, is a right angle. Right? The only way you can know if it's a right angle is if you see the box in the corner. Or of course, there could be a whole story problem or verbiage in your question that allows you to then put those marks in the picture. But unless those markings are there, you cannot make any of those assumptions. Okay? All right, so that's our quick little intro into angle basics. Tomorrow we'll be talking a lot more about angle pairs and how they work together with one another, which will kind of finish off the rest of Unit 1 for us.